Welcome to this segment of the Math Coach. Today we're going to take a close look at some of the problems in unit number 4, proportional reasoning. But before we get started, I'd like to give a big shout out to my peeps at Explain Everything, who have designed this app to help teachers like me create videos for students like you. I can't wait to get started. So let's take a look at page number 4 and setting up a problem that looks like this. These are ratios. This is x to 9 equals 5 to 3. So setting up this ratio, making the ratio a proportion, I'm going to write this first variable over the second number here. So on this side, I'm going to go x over 9. That is rewriting this proportion into a proportion, this ratio. You could have written 9 over x, but I'm choosing to write x over 9. And on this side, I'm going to keep it the exact same order. I'm going to write the first number over the second number, 5 over 3. So it's very important when you go to switch this ratio into a proportion that you keep the ratio in the exact same order. So I wrote the first number here, the x over 9, okay? And so I did the exact same on this side. I wrote the 5 over 3. The first number over the second number. Now it asks us to solve for this variable x. How do you solve for x? Well, if you looked at some of the videos that I had sent you, you would see at this exact moment what they would do is this thing called cross multiply. See, if we want to get rid of this number 9, this is x divided by 9. If we wanted to get rid of 9 and bring it to the other side, the opposite operation of division is multiplication. So hence the name cross multiply the 9. They also will cross multiply the 3 because this is 5 divided by 3, bringing 3 to the other side. This is called cross multiplying. So on the one side, when you do 3 times x, you end up with 3x. And on the other side, when you do 9 times 5, if you took your calculator out, you would end up with 45. So you end up with 3x equals 45. Now, in order to, I'm just going to rewrite this, so 3x equals 45. Now, in order to solve for x and figure out what x is equal to, I got to get rid of this 3 that's here. Now, this is 3 times x. So if I wanted to get rid of the 3, the opposite operation of multiplication is division. So I would divide both sides by 3. 3x divided by 3 is just x. And then on the other side, I have 45 divided by 3, which is 15. So x is equal to 15. Now I'm going to actually talk about this, doing it another way. So I'm going to set up the problem the exact same way. X over 9 equals 5 over 3. Now, we understand that the thing that we are looking for is the unknown number, which is x. So I understand that the videos I've sent you ask you to cross multiply and so forth, but just understand that if you wanted to figure out just what x is equal to, right? You just want to figure out what x is equal to at the very end. What do you really have to do? See, x is almost all alone on this side already. The only thing that is bothering the x is this 9 right here. So if I wanted to bring 9 to the other side, all I have to do is instead of x divided by 9, you do the opposite operation, which is multiply. So cross multiplying the 5, okay? Just like we did a second ago. Now, let me just say this. You actually don't need to cross multiply that 3. Because if you just cross multiply the 9, what ends up happening is x is alone on this side now. And on the other side, 9 times 5 at the top of that fraction is going to be 45 but you still have 3 on the bottom. And so when you do 45 divided by 3, you get 15. I mean, some people that are a little better at understanding the algebra behind the math are able to think of it this way. Others, they may want to cross multiply both numbers and then get rid of the 3 later, and that's fine. There is actually even more ways of doing this problem, and the other ways will actually help you do those proportions that involve 3 numbers. So, for instance, if you wanted to set up this another way, instead of writing one side, so proportions can be rewritten many different ways, but instead of writing one side altogether and the other side on the right, what we can do is we could actually write the first number on this side over the first number on that side. So we could actually write this as x over 5 is equal to, and then on the other side, the other fraction will be the second number over the second number. Okay, so I will write x over 5, the first number on the left over the first number on the right, is equal to the second number on the left, which is 9, all over the second number on the right, which is 3. So you could have actually rewritten this proportion like this. And this would actually end up with the exact same answer as what you did. So if I wanted to cross multiply both numbers, I would cross multiply the 5 to get rid of the fractions, cross multiply the 3. And so I end up with 3x is equal to 5 times 9 is 45. And then to get rid of this 3, this is 3 times x, I would divide both sides by 3. And so I end up with x equals, and I get the exact same answer of 15. So there's plenty of ways of doing the exact same question. Let's take a look at the second question here. So the second question asks us, it says 7 over 4, or 7 to 4, is equal to 21 to n. So there's plenty of ways of rewriting this. I mean, I can go about the first way that I rewrote the question number 1. So I'm going to rewrite this as 7 over 4, right? The first over the second is equal to, on this side, I will also do the first over the second. So we don't have a choice. If you write the first number over the second number on the left side, you have to do the exact same thing on the left side. You can't pick the order you want. You have to stick to the same order you initially picked on the left. Another way of starting this problem off, I mean, you could have written 4 over 7 if you wish, the second over the first, but that would mean on the other side, you would also have to write the second over the first. Okay? Notice some people like to write this option instead because the variable is on the top. It shouldn't matter though, because we should be able to complete this problem regardless of the variables on the top or the bottom. The next step would be cross multiplying. So I cross multiply the 4 and I cross multiply that n. So on the one side, I'm going to have the n times 7, which is 7n. And on the other side, I have 4 times 21, which is 84. Then, in order to get rid of this 7, this is 7 times n, I would divide both sides by 7. And so 7n divided by 7, I'm left with just n. And then 84 divided by 7, I am left with the number 12. So n is equal to 12. I mean, you would have gotten the same answer if you chose to do it this way here. The second over the first is equal to the second over the first. I'll show you that again. If you chose this and you did the cross multiplication, you would end up with, well, on the left, you would have 21 times 4, which is 84. And on the right, you would have 7 times n, which is 7n. Okay, you don't need to do these all different ways. You just have to stick to one way, and it's fine, whatever you chose. It's just a matter of setting up the proportions correctly. So then over here on this one here, to get rid of the 7 in front of the n, I would have to divide out both sides by 7. And basically you're doing the exact same as what you did over here, okay? And so you end up with n is equal to 12, all right? You could still write this, you could still read this as n is equal to 12, all right? And once again, I'll do this one extra time. I'm not going to do all of these a bunch of different ways, but I'm going to show you this one another way. Remember, the last option would be that you could actually rewrite this proportion as the first number on the left side over the first number on the right side. So you could have actually written this as 7 over 21. So since I started with the left side and ended off with the right side, I would do the exact same thing for the second number. So I wrote the first number on the left over the first number on the right is equal to the second number on the left over the second number on the right. So that's the other option. So you relate both first numbers, and then it's equal to the relationship between both second numbers. But you have to keep them in the same order. If you began with the left and wrote 7 over 21, you would have to begin with the left again and write 4 over n. And when you do it this way, the same thing happens. When you cross multiply, you're also going to end up with 7 times n is equal to 84. So we're going to end up with this line again. And so when you divide both sides by 7, you're going to get that the 7 is gone, so you end up with n is equal to 12. Okay, so regardless of which way you do it, you just have to make sure you set up the proportion properly, and this will help you do those with 3 numbers, which I'll show you in a second. But let's do these other 2 very quickly. I'm not going to show you how to do this 4 different ways. I'm just going to do it once. So let's take a look at the next question here. And so the next question has 24 to k is equal to 105 to 15. So let me write this just simple, basic. I'm going to write the first over the second is equal to the first over the second. So on the left, I'm going to write 24 over k is equal to 105 over 15. So I'm not going to do this 3 different ways. You don't have to do it 3 different ways. I'm just showing you different options. And then when you do your cross multiply, you cross multiply both things here. On the right, you have k times 105, which is 105k. And on the left, you're going to have 15 times 24, which is 360. Okay? And then, of course, I got to get rid of that 105. How do I get rid of the 105? This is 105 times k. So if I wanted to bring the 105 to the other side, I have to divide both sides by the 105. And so 105 divided by 105 is just 1. So this is 1k. And then on the other side, when you do 360 divided by 105, it is not a nice number. So what do you do in a situation like this? Well, in a situation like this, you're going to have to reduce the fraction. You're going to have to keep this as a fraction. I know 360 divided by 105 is 3.4 something something, but we're not going to write that because that decimal goes on forever. So how do you reduce this? Well, I noticed that both top and bottom are divisible by 15. I mean, some of you may have not noticed that, and that's okay, because some of you have a fraction button that we discussed in class that you know how to use. I mean, you could just type that fraction in and it would actually reduce it for you. Nonetheless, both top and bottom are divisible by 15. When I do 360 divided by 15, I get 24. And when I do 105 divided by 15, I get 7. So k is this fraction, 24 over 7. Let's take a look at the last question on that page, number 4. And let's, I guess, do this question the exact same way we've been doing every other question. I mean, you could choose which way from number 1 and number 3. I showed you 3 different ways that you could set up that proportion. Nonetheless, I'm going to set up the proportion the easiest way, which is the first over the second on the left side. So A over 5. And I'm going to do the exact same on the right side. I'm going to write the first over the second. 24 over 12. Okay? And then obviously doing your cross multiplying, I'm going to do 5 times 24 on that side, 12 times a on this side. So when I actually do the 12 times a to the other side, to the left side, I end up with 12a. And when I do 5 times 24, I end up with 120. So from here, we got to get rid of the 12 on both sides. So all I'm going to do is divide both sides by the 12 so that a will be alone. So dividing the 12 on this side, I'm just left with a. And on this side, I will be left with 10 when I do 120 divided by 12. So a is equal to 10. Now on page 5, a lot of you have been asking me about a question that looks like this. This question has 3 numbers on the left and 3 numbers on the right. Now, it would be impossible to follow, I guess, the easiest, simplest thing. Remember, I'll remind you, when we have something like 7 to 3 is equal to x to 5, this was very easy. There's only 2 numbers on each side. So you write the first over the second. So first over the second is equal to the first over the second. So x over 5. And then we can go about doing our cross multiplication and figuring out what x is, and that's fine. But remember, I also showed you that if you have 7 to 3 is equal to x to 5, I also showed you that you didn't have to write the first over the second equals first over the second. You could have actually written the first number on this side over the first number on that side. So you could have written 7 over x is equal to the second number on the left over the second number on the right. So the second number on the left over the second number on the right. That would still be following your proportion rules. So you're always beginning with the left side, but you did the first number on the first side relative to the first number on the second side. And then you went for the second number on the first side over the second number on the right side. Okay, so you're able to write this proportion this way as well. That's going to help us with this because there's no way of us writing 3 numbers, 6 over 2 over 4 or some ridiculous thing like that on one side, and then on the other side we write 24 over x over k. There's no such fractions that have 3 numbers in them. This is not the right way of doing it. We're going to have to revert to doing something like what I have shown you here. So the only way you could possibly do this question is actually set up 3 different proportions. You're going to set up the first number over the first number. Okay, so you're going to set up the first number on the left over the first number on the right is equal to, and then we're going to do the second number on the left over the second number on the right. So it's equal to the second number on the left over the second number on the right. And we can actually use this information right now to go and solve for x. We can forget about the third stuff right now and just go and solve for x. I mean, you have on the left side 2 numbers on both top and bottom, and on the right side you have one thing that's missing, the x. So you could actually from here now go solve the x. Forget about the 4 and the k for now. So we can actually cross multiply the 24 times 2 on the right side, and that would give me 48. And then I can cross multiply the x times 6, and it would give me 6x. And obviously, in order to get rid of the 6 on both sides, I would have to divide out the 6. So 6 divided by 6 just will leave me with 1x. And 48 divided by 6 is equal to 8. so x is equal to 8. So that's how you would figure out x. Now we can continue. We could do this again. I mean, we could set up another problem except involving this time the 4 and the k. So let's set this problem up again. If I were to set this problem up again, let me write the first number over the first number. Okay, again. So I'm writing the first number on the left over the first number on the right, and that is equal to. Now, of course, we already took care of the second number over the second number. We found x. We're trying to find k. So let's forget about the 2 and the x. I'm going to write on the right side the third number over the third number. And if you could see this, this is set up again, once again, for us to solve for k. I mean, on the left side, we have two numbers. We have a number over a number. And on the right side, we have a number over a number. So we have enough information to continue this problem. So what I'm going to do is I'm going to cross multiply the k, and I'm going to end up with 6 times k on one side. Cross multiply the 4, and I end up with 24 times 4, which is 96. And then in order to get rid of the 6, because this is 6 times k, I'm going to do the opposite operation, which is divide by 6. So 6k divided by 6 is just going to leave me with the 1k, and 96 divided by 6 is going to leave me with 16. Okay, so you end up with k is equal to 16. Now, I hope some of you are thinking exactly what I'm thinking. Sir, how about if you didn't do it the way you did it? How about if you wrote the second number, right? So how about if you started with the second number 2 over the second number on the right, x is equal to, and then you wrote the third number on the left, 4, over the third number on the right, k. Can you do this? I mean, yes, this is actually correct, but this would be impossible to solve for k and x at the exact same time. If you decided to cross multiply this, you would end up with, on the right side, 4 times x, which is 4x, and on the left side you have 2 times k, which is 2k. I mean, it doesn't matter if you divide out the 2 from both sides or the 4 from both sides. You cannot figure out k and x at the same time. It would be impossible to do that. So how do I know where to start? Well, in actuality, I'll teach you exactly what you should write at the beginning, and that would be all three proportions with equal signs. So the real way of writing this or starting this problem would actually be the first number on the left over the first number on the right is equal to, and then you're going to write the second number on the left over the second number on the right is also equal to the third number on the left over the third number on the right. This is actually the way that this proportion works. All three of these proportions are equal. Okay, so if all three of these proportions are equal, how do we solve for x, and then how do we solve for k? We have to separately solve for them. So the way I would do that is I would first solve for, let's say, x. If I were to solve for the x first, I am going to make sure that I kind of erase this little bit from my head, and I would focus in on just these two fractions, because it's impossible to deal with 3 fractions and 2 equal signs. So if I set up this, that's this right here. So I would go out and solve for x first, and I do that by doing this right here. And I go about my steps, and I'd figure out x, and once I have x, then I would find k. So I would find k the exact same way as I thought about finding x. How do I find k using these 3 fractions? Well, I know that I have to have a fraction that has both numbers on top and bottom. So if I'm finding k and I'm interested in finding the k value, I'm going to erase the other unknown value like this. And I would focus in on this fraction, 6 over 24, is equal to 4 over k, which is right there. All of those fractions are equal to each other. So I pick two fractions at the same time, make them equal to each other, and solve. What I do not want to do, once again, like I said, it is impossible if you kept these two fractions and tried to solve. 2 over x equals 4 over k. That you do not want to do because it would be impossible to find x and k at the same time. So no matter what, we are keeping 6 over 24, and we're dealing with one of the other fractions separately. So we'll actually move on to some of these examples. So on page 6, it asks us to solve another proportion with 3 terms. So how do we do that? I mean, if you were stuck, a great place to go look at videos would be YouTube. And you would just type in this exact same thing. Solve proportions with 3 terms, and I guarantee you there will be some sort of math teacher online or some student teaching you how to do that. Nonetheless, how do I solve this? Again, if there's 3 terms, there's no way, no how I'm going to write 8 over 9 over m on one side equals 12 over n over 24. I mean, this is not good thinking because there's no such thing as these fractions. So I'm going to do this the other way that I had mentioned. I'm going to make proportions in order. I'm going to make a proportion between the two first numbers. So in this case, I'm going to write 8 over 12 is equal to, then the proportions of the two second numbers in that same order, left, which is 9 over the right one, which is n. And then the last proportion, I'm going to obviously make a proportion between m and 24. Since I start on the left, I'm going to write the left number first, the m over 24. So I made a proportion between the two first numbers, and I start on the left. So first left number over the first right number, then the second left number over the second right number, third left number over the third right number. So I end up with this scenario right here. Remember from the last example, there is no way that we can solve this all in one shot with 3 fractions and 2 equal signs. But we can break this up into 2 questions. The first question I would break it up into would be, if I wanted to figure out n first, I would kind of just erase this from my head right now, and I would write 8 over 12 is equal to 9 over n. That's how I would figure out n. At the same time, if I wanted to figure out what m is, I would erase this middle fraction, and I would have set up that 8 over 12 is equal to m over 24. So that's how you would set this up. Even though you have 3 different fractions here, all the fractions are equal to each other. So I picked 8 over 12 equals 9 over n, and then 8 over 12 also equals m over 24, because all of these fractions are equal to each other. Now, if I go to solve for n, no problem, I'll cross multiply the n. N times 8 is going to be 8n. And I cross multiply the 12, and 12 times 9 is going to be equal to 108. Dividing the 8 from both sides, I'm going to end up with that 8 divided by 8, this will just leave me with 1n, and 108 divided by 8 is 13.5. Now this is okay to write as a decimal because this is not a repetitive decimal that goes on forever, like the other example that I had in the first page there, from page number 4. Continuing the question over here, 8 over 12 equals m over 24. Again, cross multiplying both numbers, I end up with 12 times m, which is 12m. And 24 times 8, which is 192. And then in order to get rid of the 12, I'm going to have to divide the 12 from both sides because that's 12 times m, opposite operations division. So 12m divided by 12 is just 1m, and 192 divided by 12 would give me 16. So that would be the proper answers for those. Question number 2 also has a proportion that has 3 numbers, or ratio that has 3 numbers. So once again, we're going to have 3 different proportions. I'm going to have to write this as the first number on the left over the first number on the right. So I have 8 over 12 is equal to, and then I'm going to write the second number on the left over the second number on the right. So it's equal to 6 over f. And then I'm also going to write the third number on the left over the third number on the right. So I'll always start from left to right so that I don't make a mistake here. So we end up with this now. All of those proportions are equal to each other. Remember, proportions are just fractions. So those 3 fractions are equal to one another. How should you split these up? If I want to find f, I should forget about g right now. So how do I do that? So the first one will look like this. 8 over 12 is equal to 6 over f. So when I want to find f, forget about g. Similarly, if I want to find g, I would forget about f. So I'd write 8 over 12 is equal to 10 over g. And this is how I would solve for both. I set them up properly. So all 3 of those fractions are equal to each other. All 3. So 8 over 12 is equal to both of those. That's what I've written here separately. So now, cross multiplying, I'm going to get f times 8 on the left. And so I get 8f. And on the right, I have 12 times 6, which is 72. And then to get rid of the 8 times f, I would get rid of the 8 by dividing the opposite operation. So 8 divided by 8, this would just leave me with 1f on that side. And 72 divided by 8 is going to give me 9. So these aren't that bad as long as you know how to set them up. Then doing the same thing on the second one, I have over here cross multiplying both numbers. So I have 8 times g, which is 8g. And then I have 12 times 10, which is 120. And remember, this is 8 times g. So to get rid of the 8, I will do the opposite operation, which is divide both sides by 8. So that gets rid of the 8, leaving me with just g here. And then when I do 120 divided by 8, I end up with 15. So g is equal to 15 in that case. So hopefully that helps you solve those tricky ones with 3 different ratios. So if we turn to page 8, we're going to deal with a lot of discounts of prices. And let's look at question 1. It says, Carl bought a jacket with a regular price of $129.49. So that's the regular price of the jacket. The jacket was on sale for 30% off. So 30% is the discount. Remember, discount is just money that this person is saving. Okay, so that's what a discount is. How much money is the person saving? Okay, and then it says, so the jacket was 30% off and taxes were 13% HST. So we'll deal with the taxes later. Determine each amount. So first off, it asks us for the discount. So how much is this guy saving on the jacket? Not what the jacket's price is going to be. How much is he saving? So remember, the ticket price, it says to take 30% off. So we're going to figure out what 30% of $129.49 is. that would be the discount. Now, what is this sentence, 30% of 129.49 cents, actually mean? Well, we should know from previous units what 30% is as a decimal. If we take 30% and you divide by 100, you're going to get this percentage is actually 0.3 or 0.30 as a decimal. Okay, so we're first going to convert this percentage to a decimal, which is 0.30. Of means multiply, and we already have this amount of $129.49. When we do this, 30% or 0.30 times that number, we end up with this number here, $38.84, and then you have a 7 here. So we never round money to the nearest 3 decimal places. We always round to the nearest penny, which is 2 decimal places. So this is actually $38.80. Should I leave that as a 4 or should I round it to a 5? Well, since the next number is 7, I'm going to round this up to a 5. So it's $38.85 that this person, Carl, is saving. That's how much discount they're going to subtract from the price of the jacket. That's how much he saves. So, which brings us to our next question, the sale price. So what is the sale price? The sale price is always just going to be the regular price, okay? So the regular price, and we're always going to subtract the discount. So the sale price is always whatever the regular price is, which we know is $129.49. And then we're going to subtract how much Carl is saving, which is that amount, $38.85. So that's all I'm going to do. I'm going to take $129.49 and I'm going to subtract on my calculator. I'm going to subtract how much he's saving, which is $38.85. And this will end up giving me a total of $90.64. So that will be the sale price of the jacket after you have discounted the 30%. Then it asks me actually to figure out what the tax is. So if we want to figure out the tax, we're going to have to remember that tax is always this number here, 13%. Okay, HST in Canada, or sorry, in Ontario, that's how much we're always going to pay in tax. We're going to pay 13%. So we have to figure out what 13% tax is on this sale price. So I just scrolled down here, and so I know that the sale price is $90.64. Now let's figure out 13% tax. So 13% of $90.64. And so what does 13% of $90.64 mean? Remember what 13% is. As a decimal, if we take 13% and we divide it by 100, we end up with 0.13. So that's 13% as a decimal. So 13% is written as 0.13. Of means multiply, and I'm going to multiply by $90.64. So I could figure out how much the tax is, because we know that tax is always 13% in Ontario. And so I just do these two numbers multiplied by each other, and I end up with 11.7832. Now we know that, of course, we are always going to round this to 2 decimal places. So it's $11.70. Now should I leave this 8 as an 8, or should I round it up to a 9? Well, the next number is 3, so I'm going to leave it as an 8. Okay, so $11.78 is the tax. That's how much tax you have to pay. So this is the sale. The sale price is $90.64 right here. This is how much tax that you have to pay for buying the jacket. Now, how do you calculate the total amount? The total amount is always the sale price. It's always the sale price. And you have to always add what you pay in tax. So that's how you find the total amount. And so the sale price we know is $90.64. And we're going to add the tax, which is $11.78. And so the total price will be $102.42. So this will be the total amount Carl has to pay after you have taken away the discount and then you've added your tax. So let's take a look at the next question. On page 9 it says, Mr. E bought a soccer jersey with a regular price tag of $79.99. So that's the regular price. The jersey was on sale for 25% off. Determine the total amount including tax. So first off, let's figure out the discount. So how much is he saving? So we're trying to figure out his savings. Okay, and how much he's saving is 25%. He's saving 25%. So we are trying to figure out 25% of $79.99. Okay, now 25%, if you're writing that as a decimal, 25 divided by 100, it's going to give you 0.25. Of means multiply, and we're going to multiply this by $79.99. When we do this, we're going to end up this number here, 19.9975. So what do we do with this number here? Well, I ask myself to round to the nearest penny. This is the nearest penny. Should I round this up a penny or leave it as 19.99? Well, the next number after the 9 is a 7, so I should actually technically round this number up by a penny. If I rounded this up by a penny, that would make this 19.99 actually an even $20. So that's the proper amount that I would round to. So the amount of discount, the amount of money he's going to save is $20. So I just scrolled up here. What is the sale price? Remember, the sale price is always the original amount, which is in this case 79. So it was $79.99, and we're going to subtract the discount. So the discount is $20. I wrote this all in words on the last problem so you could look back at that. And so you're going to end up with $59.99. That is the sale price. How much will the tax be? Well, we all know that tax in Ontario is going to be 13%. So we are going to do 13% of that sale price, which is $59.99. 13% as a decimal, when you divide by 100, it's 0.13 multiplied by $59.99. Plugging that into our calculator, when you do this, you get 7.7987. We're going to round this to the nearest penny. The nearest penny is right here, 2 decimal places. So should I leave this as a 9, or should I make this go 1 penny higher? Well, the next number is an 8, so I'm going to add a penny to this. So it's going to be, instead of $7.79, it's going to be $7.80. That is how much tax that Mr. Eid will have to pay. Then it asks, how much is the total amount? Remember, I wrote it in words before, but total amount is always going to be the sale price, which is $59.99, and you will have to add the amount of tax that you have to pay on top of the sale price, which is $7.80. When you add these two numbers, you get $67.79. So that amount here is the price of the jersey minus the discount, and then add tax on the discounted price. So let's go back to page number 7 and let's look at unit rate. So a rate. A rate is 1 unit rate is the price of one item. What is the price of one item? So for example, how about if you sell 10 pens for $6? Determine the price of one pen. Well, this is why we have this formula up here. The total price, okay, is $6, and we are going to divide this by 10 pens. And when we do this, we are going to get $0.6 or $0.60 for one pen, otherwise known as 60 cents. So each pen costs 60 cents. And then, there's a box of 10 of them, so you multiply that by 10 and it's $6. So that's what unit rate means, is what is the price for one of those items, even though the items are sold in a bundle. So this question asks us to determine the best buy for each of the school supplies. Show your calculations, do not round. So over here you have two options. For pens, you have a box of 8 pens that are selling for $2.59, or you have a box of 12 pens for $3.35. So which box is better to get, or which is the better deal? So in order to determine the best deal, we should figure out how much for one pen in that box and how much for one pen in that box, and determine which box is cheaper per pen. So how do we do that? Again, we have the total price for this box, which is $2.59, okay, and we're going to divide it by 8 pens. And when we do that, we will get a unit rate of 0.4316, and this goes on forever. Okay, we're obviously going to round this to the nearest penny, which is 2 decimal places, so it's 0.4. And now, should I round this 3 up to 4, or should I leave it as 3? Since the next number is just a 1, I will leave this as 3. So it's 43 cents per unit. That's why it's called unit rate. Per one pen, every pen in that box costs 43 cents. In box number 2, you have 12 pens for $3.35. And so figuring out the unit price in this box, the unit rate, we're going to do the exact same thing. We're going to take the $3.35, but this time we're going to divide it by 12 because there are 12 pens in that box. So in this particular case, when we do I'm going to get 0.2791, and that number goes on for quite a while. However, I'm going to round this to 2 decimal places, which is 0.2, and I should round this 7 up because the next number is a 9, so $0.28, which is otherwise known as 28 cents. So the box of 8 pens that sold in red here that I have highlighted, that sold for $2.59, were 43 cents a pen, but the box of 12 ended up being 28 cents a pen. So I am going to choose the box of 12 because it is a better deal. Those pens are only 28 cents each. Let's look at question B. Question B is similar. you have two options here. You have 250 sheets of graph paper for $2.49, or you have 135 sheets for $1.15. Which one is a better buy? Well, we have to figure out how much each sheet costs. So we're going to figure out the unit rate per unit. Okay, so each unit over here, or each sheet of paper in this case, is going to cost, well, remember you always put the price at the top, and this is just a proportion or a rate, and you're going to divide by 250 sheets. And when you do this, you're going to get 0.00996. Let's actually round this to the nearest penny, which is 2 decimal places. So it's 0.0, and should I round this up or leave it as 0? Well, the next number is 9, so I'm going to round that up. So it's basically a penny a sheet. In the second one over here, when I look at the next box, I have 135 sheets for $1.15. So figuring out the unit rate here per sheet, I'm going to take the $1.15 and I'm going to divide it by 135. And so this unit price is going to be 0.0085158 and so forth. Now I'm going to round this to the nearest penny like my teacher always asks me to do. So this is 0.0. Now this I should round up because the next number is an 8, so I should round it to 1. So it looks like the 135 sheets are also a penny, but that's actually not true. Since we rounded both answers to a penny, it seems as if both are a penny, but we'd have to go a step backwards in this particular case to figure out which one's cheaper. This one has this number actually, that's the unrounded number, 0.00, and then there's a 9. But this one has 0.00 and then there's an 8. So this one is actually cheaper. If we looked back enough decimal places, even though they're very close, both are very close to a penny, in the long run, this one here is cheaper than the first option. So let's look at page 12 and let's look at this challenging problem right here. This one has to do with scaling. So it says a particular motor mix contains cement, water, and sand in this ratio, 2:1:6. So it's 2 parts cement, 1 part water, 2:1, to sand is 6. So you need 2 parts of the cement, 1 part water, and 6 parts of sand in order to make this motor. So this mortar, it says how much cement and water should be in a batch of mortar containing 11 kilograms of sand. Okay, so it's giving you the sand amount and you're trying to figure out how much of the cement and water should go there. Okay, so let's set up this ratio. So setting up this ratio, I'm going to first take the first ratio of 2:1:6, and remember this is cement to water to sand ratio, and I'm going to make that equal to, on the other side you should also have cement, water, and sand on the other side. So if they're giving me the ratio should be 2:1:6, cement should be 2, water should be 1, sand should be 6. It's telling me over here on the next line how much cement and water. So we don't know how much cement and water. We're trying to figure out how much cement and water should there be in a batch of mortar that contains 11.4 of sand. So they're giving me on the other side that the sand is 11.4. So we know initially it's 2 to 1 to 6. And the second sentence says, if you have sand at 11.4, how much should you have in water? We don't know. So I'll just write W over here. And how much should we have in cement? I don't know. So we'll just write C for cement there. So this is the proper proportion that you should have, or ratio that you should have come up with. 2 to 1 to 6 is the same as cement, which we don't know, to water, which we don't know, to the sand, which is 11.4 kilograms. And now we can solve this by using my other examples. But I'll continue this one for you. How do you set up the proportions? Well, since it's one of those ratios that have three numbers, the proportions will go as follows. I'll start always on the left, so the first number on the left over the first number on the right, so 2 over C is equal to, and then I'm going to do the second number on the left over the second number on the right, 1 over W, which is equal to, and then I'm going to write the third number on the left over the third number on the right, 6 over 11.4. Okay, so this is the proper proportions now. And how do I solve those proportions? These proportions, remember, what are you trying to solve? You are trying to solve for W separately, and then you're going to try to solve for C separately. So if I was going to solve for W first, I would not worry about the C proportion. I would just worry about the W and the other numbers. So the first proportion I will actually have is 1 over W is equal to 6 over 11.4. So that's the first one. The second proportion, if I wanted to find C, I would just want to find C and not worry about the W. So I would set up the second proportion as 2 over C is equal to 6 over 11.4. So finishing this one off for you, the first thing you're going to do is cross multiply. So you're going to have on the left side 1 times 11.4, which is 11.4, and then W times 6, which is 6W. Isolating the W, so getting rid of the 6, I'm going to divide both sides by 6, and so I will get W is equal to 1.9. Okay? Similarly over here, cross multiplying both over here, I'm going to get C times 6, which is 6C, and 2 times 11.4, which is 22.8. Okay? And then I apologize, I ran out of room here, but I'm going to divide both sides by the 6. I'll continue this up here. And when I divide this by 6, I get C. And on the other side, when I divide 22.8 by 6, I get 3.8 as how much cement should go in there. Therefore, there should be, and you could end off with a therefore statement. So therefore, there should be 3.6 kilograms of cement and 1.9 kilograms of water mixed with this 11.4 kilograms of sand. So let's look at scales. And this question here, number 4 with the ant, you could find that on page 12. It says a picture of an ant is given below. Determine the scale if its actual length is 2.4. So what we did here is we actually took out a ruler and we measured this with a ruler, and this is 58 millimeters. Okay, so we know that the scale is always the diagram measurement to the actual measurement. That's what the scale is. You can find that on page 11. It says that scales are always the diagram measurement to the actual measurement. In this diagram, the measurement in the diagram of this ant is 58 millimeters. And it says that the actual length of the ant is 2.4 millimeters. Notice they're both in millimeters. Okay? Now, how do you solve a scale? Remember, a scale is always diagram to actual. Now, in order to solve, we always want the diagram number to be 1. So 1 millimeter is the same as something in real life. Okay? And so the only way that we can do that is we take a look at the number over here on this side, and it's 58. Now, whatever you do to one side, you got to do the exact same thing to the other side. In order to change this so that the 58 is a 1, what we're going to do is we're going to divide both sides by 58. Remember, whatever you do to one side, you do to the other. It's like a fraction. Remember that a ratio is actually a fraction. And whatever you do to the top of a fraction, you do to the bottom of the fraction. So I'm going to divide both sides by 58. Now, when I do that, 58 divided by 58 leaves me with 1, which is exactly what I want, because I always want the diagram to be 1. 1 millimeter on this diagram is, and then it will give me the actual in real life. So now I'm going to take this 2.4 and divide it by 58. And I will get 0.041379331. This is the scale. And no, we're not going to round to 2 decimal places because this has nothing to do with money. However, this is the scale. This is why we have learnt unit rate, because a scale is a unit rate. It's always 1 on the diagram side, and then whatever the number should be on the actual side. Let's take a look at this car question. Again, this says the wheelbase of a vehicle is the distance between the front and back axles. Determine the actual wheelbase of the vehicle in this scale drawing. Now, remember that the scale drawing always is, and the ratio that's set up is always the diagram to the actual measurement. Now, we actually took out our ruler and measured this to be 2.9 centimeters, let's say. And it's also telling us that the scale is 1 to 50. And so we are trying to figure out what the actual size of this vehicle is. So this time it gave us a scale. Remember, the scale it's giving us is 1 to 50. And that's going to be equal to our scale, which we have the diagram measurement. Remember, it's always diagram to actual, okay? And so if they're giving me the scale of 1 for diagram and 50 for actual, I also have a diagram measurement of 2.9 that I can write right here, but I am trying to figure out the actual measurement. So this is the ratio that I should set up. Now, how do I solve this ratio? There's so many ways of solving this ratio, but I'll go about doing this one the same that I would go about doing one that had 3 numbers. So I'm going to set this up as the first number on the left over the first number on the right. So 1 over 2.9 is equal to, and then I'm going to write the second number on the left over the second number on the right. 50 over A. Solving this, all I'm going to do is cross multiply both these things. So on the left side, I get A times 1, which is just 1A. We don't have to write the 1 here because, it's just a 1. If you do want to write the 1, you can. And 2.9 times 50 is 105. So I'll just write that down over here. So 1A is equal to 105. I'm not going to divide both sides by 1. I mean, we should know that 1A is just A. So A A times 1 is just A. So A is equal to 105. So therefore, the actual wheelbase is 105 centimeters. Now we have similar problems on page 16. So on page 16, it has measure the length of the indicated in centimeters. What is the actual length of the shark in meters? So I actually took my ruler out here, and on the sheet of paper, I got that this is 6 centimeters. I hope that's what you got as well. I mean, I could be incorrect because I used a ruler from my iPhone. Maybe it's 6, maybe it's 7, but for the sake of the argument, I measured this to be 6 centimeters with my iPhone's ruler. Now it says measure the length indicated in centimeters. What is the actual length of the shark? This is much like the last problem. Remember, you always have two measurements. You have the diagram to the actual. Okay, always diagram to the actual is equal to diagram to the actual. Now, we have a scale that they've given us already. They're telling us the scale is 1 centimeter in real life is 70 centimeters. 1 centimeter in the diagram is 70 centimeters in real life, right? Similarly, the actual diagram that I have measured is 6 centimeters. So that's what goes here. But I don't know the actual measurement of that shark. That's what I'm trying to find. So this is the setup of those two ratios. Diagram to actual is equal to diagram to actual. Setting this up, I'm going to set this up like I normally do. The first number over the first number. So 1 over 6 is going to be equal to, and I will write the second number over the second number. 70 over A. Cross multiplying these, I will get A times 1. We've discussed this. This is just A. And then I will get 6 times 70, which is 420 centimeters. So therefore, the actual length of the shark is 420 centimeters. Now the next question is a little different. This question 6. It says a stop sign has an actual width of, so this is the actual width of 60 centimeters. Determine the scale of the diagram below. The diagram width though is 3.6 centimeters. So remember, any of our diagrams is always going to be, our scales are always going to be diagram measurement to actual measurement. Now, the diagram measurement in this case is 3.6 centimeters. The actual measurement in this case is 60 centimeters. So this is the diagram to actual. However, we have to bring this down to a unit rate. Remember, whenever we have a scale, a diagram to actual, we always want the number in the diagram to be 1, and then we figure out the actual. How do we do that in this particular case? Well, we're going to have to divide both sides by the 3.6 so that we can make that 3.6 a 1. So if we divide both sides by 3.6, on the left side, 3.6 divided by itself is just 1. So we're dividing both sides by 3.6. And 60 divided by 0.6 is 16.6666, and this goes on for a few sixes with a 7 at the end. So that is actually the scale of this diagram below. The last question I'd like to take up is this question 4, and it can be found on page 18. It's a pretty tough question. It says the Canadian flag has a width to height ratio of 2 to 1. So that's its ratio for width to height. So the width is 2 and the height is 1. Then it says on a scale of 1 to 50, so on a 1 to 50 scale drawing of a flag, its width is 13 centimeters. What is the actual size of the flag? So what is this telling us? What this is telling us is that in the drawing here, this width of this flag is 13 centimeters, okay? That's the width right here. We also have to figure out what the height of this drawing is, right? I mean, if the width is 13, they also give us a scale width to height ratio. And remember the width to height ratio in the first sentence. So width to height, they're telling us is 2 to 1. So the width is 2 to height is 1. Now in our drawing, we know that the width is 13.0. So 13 for the width. We don't know what the height is of our drawing, but we do know it's in the ratio of 2 to 1. So we could actually figure out the height of this drawing right now using that ratio there. So that's what I'm going to figure out. How do I set this up? Well, I'll set this up the same way I always set it up. I will set up the first number over the first number. So I have 13 over 2 is equal to the second number on the left over the second number on the right, h over 1. Now when I cross multiply to figure out that height, cross multiply, I'm going to get 2 times h on the right side, which is 2h, 1 times 13 on the left side, which is 13. Then, of course, divide both sides by 2 to get rid of the 2 there. And when I divide both sides by 2, I end up with h is equal to 6.5. So the height of my flag, the drawing, not even the real life one, is 6.5 centimeters. So this is the height of this thing. Now, it says, on a 1 to 50 scale drawing of a flag, its width is 13 centimeters. What is the actual size of the flag? So what is the actual width? So, and then what is the actual height? So first off, I'm going to find the actual width first. Okay, so the actual width. Now we know that all of these scales, this 1 to 50, is always the diagram measurement to the actual measurement. And the diagram measurement to the actual measurement, they are telling us, is 1 to 50. Now, we know the diagram measurement or the diagram width. The diagram width is 13. So 13 to the actual width, which we don't know, is 1 to 50. Now we can solve this to figure out the actual width of that Canadian flag. When we solve this, I'm going to write the first number over the first number. So 13 over 1 is equal to the second number over the second number, a over 50. Using cross multiplication, on the left side, on the right side, I'm going to be left with a times 1, which is a. And on the left side, I have 50, which is 650. So we know the actual width of that Canadian flag is 650. Remember, we are finding width over here. Now to find the height, I'll just set it up for you. Diagram to actual equals 1 to 50. My diagram is, we know is 6.5 to the actual, which we don't know, is equal to 1 to 50. And when you complete that, you should get that the actual height is 325. Well, there you have it. Unit number 4, Proportional Reasoning Review using the Explain Everything app. Hopefully this video was helpful. Leave your comments below. I'm the math coach saying, thanks for watching and see you next time.